So let's go ahead and get started because I know we have an amazingly full session. We've got just a full complement of amazing people. My name is Nancy Ostin. I'm the director of IEEE at HKN. I have the best job in the world. I get to work with the smartest students and the most amazing people. And we're really glad that you joined us here today at Pathways. HKN is part of IEEE, which is the world's largest professional technical society. And in IEEE, we have 47 technical societies, which are great places to go for when you want to become an expert and you want to network with experts. And we have one of those societies with us. They're a great partner with HKN. It's the Communication Society. We love partnering with them. It touches a lot of disciplines, and it's great to have them with us. And I'm going to introduce a colleague of mine at IEEE, who is the Industry Outreach and Technical Activities Director of the IEEE Communication Society, Sin Sikora. Sin, thanks so much.
Hi, yes, Sin Sikora at ComSoc, and I am very happy to be here today to bring you some amazing people from the telecom industry. With us today, we have Dr. Alexandra Jelinek, and Dragan Zamadzi, and Dr. Dragan Zamadzi, and Dr. Todd Sizer. And let me tell you a little bit about them. I will say I have some background with them, and at least two of them I've worked closely with. And these guys know a lot about industry, about telecom, about research, and all of the things that I think you're really going to enjoy. So I'm going to ask you to prepare your questions, and just for my benefit, make them really hard questions, because I would like to see them tackle some hard questions. So first, Alexandra is a product manager at IS Wireless in Poland. She has worked extensively on the architecture and optimization on mobile networks, and she has her master's and her doctorate in telecommunications. Her experience in R&D is vast: product management, research. She has publications with over 2,300 citations. She works in standards. She teaches. She's a consultant. And interestingly, she's lived and worked in Denmark, Poland, France, and Taiwan. So she definitely can address questions of a global nature. Dragan is a senior research leader at Nokia Bell Labs in the United States. He does research on next generation wireless systems, and he has a focus on analysis, design, and experimental evaluation of radio access solutions. And although his background is in both electrical engineering and computer science, he received both his master's and his doctorate in electrical engineering. He is currently managing research work at 4 international Nokia Bell Labs locations. So another one who can address global questions. And Dragan teaches and mentors university students. And he's authored over 50 peer-reviewed publications, and he has numerous patents and has received the Bell Labs Fellow Award. We also have with us Todd Sizer, who is a very prestigious researcher. He is the vice president of the wireless research program in Bell Labs.
Optics.
Yes, I caught that from the other thing. He's actually leads the optical systems and device research lab at Nokia Bell Labs. He previously, for 8 years, led the wireless research program, where he drove the vision and research of 5G. And he does currently with the optical systems and device research lab, he's innovating in all aspects of optical systems and devices for access, core, submarine, and data center communications. And he received his master's and doctorate in optics. And he also received the Popular Science Breakthrough Innovation Award for the light radio invention. Todd is the author of 55 US patents. He is a fellow of Bell Labs, WWRF, as well as an IEEE fellow. So there is much more to tell you about each of them, but I would like them to each take the opportunity to describe to you a little more about themselves, but also more about how they got started in their path. So Alexandra, can you start us off?
Sure. Thank you, Sin, for an introduction. So the way I really started working in telecom, it was all, about being open-minded and surfing on the waves that were coming. So I've chosen the studies in telecom, to be honest, because I was good with maths and physics, so those were my interests. But from the whole technical university portfolio, I've chosen telecom because it was the hardest to get to. So I had colleagues that, in the childhood, they knew I want to be a doctor, I want to be a dentist, and that's great, but I never knew what I wanted to do. So telecom was just as good. And then I ended up doing mobile networks because there was this university teacher that was making mobile networks so clear that that's how it got me started on my first summer internship in the company that is now part of Ericsson. And that led me to do my master thesis in mobile networks. And yeah, I mean, I don't know if this is the moment really to take a few minutes on telling the story or, yeah.
Sure, that would be fine.
I think I have a few anecdotes along the way. So I did my master's in mobile network that resulted in an IEEE conference article. So that was great. And then I moved to Poland. I did my studies in Denmark. I moved to Poland, started working over there, technical trainings, excellent job. Then I was invited to go back to my university for a research project. And then on the day number one, they told me, okay, we will look for some PhD projects for you. I'm like, PhD, what do you mean? I came here for 1 year. I have my life in Poland. But yeah, from, looking at what are the options, I had an opportunity to apply for a scholarship for PhD, working for a company within the European project framework. So I thought, okay, I better apply. And one thing led to another. This is how I got started on an industrial PhD. So that was actually very interesting because I was employed by the company doing the research work in the direction that was strategic. And here, actually, I got to collaborate with Bell Labs, so with Todd's team. And then a few years ago, I was invited by a growing Polish company to join the team. And this is how I came back from Denmark back to Poland to start to scale the company exactly in line of my PhD. So here, really, the LinkedIn connections make the dots connect and really to a win-win. So it's a great opportunity really to combine the state-of-the-art R&D work with the industry business development. I think here is really the sweet spot of, for sure, by energy, because yeah, I think fundamental research work goes very well for some people. But I like this energy of working in the industry to have more focus on the commercialization, patenting, apart from attending the technical conferences and publishing over there. Yes.
Great, thank you. Dragon, can you tell us about yourself and your path?
Yeah. Actually, since my early days, I fell in love with nature and I wanted to understand the physical world, but I wanted to make an impact, help people and help the stuff, change the stuff around me. And actually, I ended up in engineering school, and I'm of kind of a developer mindset, meaning once you end up doing something, if you drill down deeper, they'll be fun, no matter what you do. And I was lucky back then. Those were the early days when I started my grad school of 3G, 2G, then 3G wireless communications. And what could be more fun than antennas, Maxwell equations, so fundamental. And this is how I decided to get into the wireless grad school program at Rutgers WinLab. And I was even, then my luck turned even to better. I got a job offer from Famous Bell Labs, where I met incredible people and people which tend to play with different ideas. They're very philosophical, so it's not just one thing. And of course, one of mentors was Todd Sizer, who's here, and he's a living proof how you can change from one topic, wireless, to photonics. I think, Todd, you even worked on quantum physics way back when.
Yep.
This is the nature of the group a group of people I've been surrounded by during the last 2.5 decades, intellectually challenging each other, being to the right level, the kind of even cynical just for the kicks, but you need to stop at certain point, and then be ready to grow into something new. I've heard many times, and I did it a couple of times, you want to become an expert in something, start reading conference papers, 10, 20, 30, try to do it something yourself, and after a while you become an expert. So this is what I went through a couple of times. I tried completely new things, and it was super rewarding. And again, I have to admit, I was at the right place for the last 2 decades, the place which nurtures this kind of attitude and the work style. So I'll stop here, and later on we'll get back. But I think now it's Todd's turn, right?
Okay, Todd, tell us your path.
So my path, like so many, is related to a teacher I had. So I had a professor at Amherst College, which is where I went undergraduate in Massachusetts, and he really illuminated the magic around optics and light. It was called wave mechanics or something boring like that, but he was such a good teacher. It just all made sense, and the mathematics made sense. And like Alexander, I sort of had a bent for mathematics and liked the beauty of it. So. And then I also was a bit of an astronomer, and so light and astronomy, of course, obviously go together. So I did a PhD there, or I did a undergraduate degree there at Amherst, and then went to Rochester, got a degree in optics for a short period of time, about a year. I held the record for the shortest pulse of light at 90 femtoseconds, 70 femtoseconds, and so that was sort of fun, and Bell Labs actually hired me because they had the record before me, and so they hired me. So I joined, and it's been fun. I've been at Bell Labs my entire career, but as Dragan indicated, I get bored, and so I tease my wife that I don't change my wife every 7 years. I change my job every 7 years, and so I have done that. So initially I worked on optical computing and did that for a while, and did some work in consumer electronics, and was on the organizing group for Bluetooth. So I suspect all of you have Bluetooth in your phone, and so I was involved in the late 90s in developing Bluetooth. And then I found that I really enjoyed working with people and working with talent, especially Dragan, but certainly others, including Dragan. And so have had 3 different jobs: first as a department head, then leading all of wireless research, and then leading optical research, which is what I'm doing now. And so working with smart people to encourage them to stretch and to seek answers to questions, and so that's an awful lot of fun. So I currently manage a rather large team, and in 4 different locations. I did, for a period of time, relocate to Germany and lived in Germany and worked from Germany. That was awful fun. So I really enjoy the getting to know very diverse folks So that international experience was very helpful. So that's sort of my story.
Okay, thank you, Todd. So again, I would encourage all of you listening and watching to provide as hard of questions as you can, because I like to give these folks hard questions. And I do know that they do like hard problems. So hard questions should be right up there with that. While we're waiting for your questions, I would like to ask all of you to think about your early career when you were back when they were students, young professionals. Were there any specific lessons that you learned, or maybe the most poignant lesson that you learned early in your career that you could share with this group to help them make their way through this path that they're going through? Todd, you're nodding. Maybe you have something to offer.
So yeah, I mean, I think when you were a student, when I was a student at the University of Rochester, Rochester itself has a long history in optics. So the Institute of Optics is very well known and was formed in 1929. It was pretty early, and of course Rochester was Kodak. So it was a place where there were an awful lot of senior and very established folks in the industry. And one of them was a guy named Emil Wolf. And so for those of you that studied optics, you might know the Born and Wolf text, which I used. And Emil Wolf was a professor. And one thing that I did and that has served me well and that I would encourage you to think about is don't be intimidated. So feel free to go and ask questions, even if you think they're dumb questions, of the best, the most knowledgeable people in the room. Don't be scared just because you're in the position you're in, because you might learn something. Now, your question might be silly, but Dr. Wolf, in my particular case, I probably asked a silly question. I can't even remember what it was. But he was kind and gave me good feedback, and it established a rapport that led to more conversations, including those that helped me define what the research was that I did for my PhD. So I would encourage you to be brave, reach out to the best people in the room and ask your questions, seek their advice, because you never know what could happen.
That's great advice. Alexandra or Dragon, do either of you have any early lessons in your career that you can share with the group?
Alexandra?
Yes, maybe I can actually show you the picture I had in mind. So it should be coming up. Is it?
Yes. I see it now.
Yeah, so my general takeaway and the denominator of all the thoughts I have for you today is to be open-minded. And it can be both about taking the opportunities, knowing what you are interested in, what you are good at, and what is needed in the world, and then seek what is coming and what to do with it. What can you make the best out of it? And you can take it in both ways, for opportunities, but also for challenges. Just a side note that many waves are coming at you, and why not to serve them? Yeah.
Wow, great.
Okay, I can speak about the first boss of mine. Some of you, especially in the IEEE community, know him well, Rinaldo Valenzuela. He taught me a couple of things, some of those explicitly, some of those I've learned myself looking at him and consequences the style of work provoked. First of all, you need to be very critical. Try to be analytical. Try to exchange thoughts verbally, clearly with your team. For many people, not all of them, but for many people, verbalizing yourself, putting your thoughts in a coherent train of words does a magic. So analysis, criticism, very good. Do not follow false gods. There are no gods, so to speak. However, at certain point, you need to take a break and kind of suspend a disbelief, because we can always create another layer of why doing this, it's to the point of getting meaningless. But at certain point, you need to suspend the disbelief and make some progress. And that progress could be tough. So you cannot be discouraged. You need to drill down deeper. There are so many smart people behind you and will be ahead of you, but this should not be a reason why you should stop drilling down deeper. So analyze, verbalize, have a team, be honest to the team yourself, have this kind of intellectual, technical honesty. But at certain point, to be productive, you may need to stop with that kind of a critical analysis and do some real work. And of course, getting back to analyzing what's been accomplished after that. So these are the early lessons learned, and I think they have shaped me since ever.
Okay, great. Thank you, Dragan. Thank all of you. Those were great tidbits to help the students. Michael Trailer is asking a very specific question about telecom that I'd like to share with you. So I'm going to ask you each to address, how do you see the telecommunications industry growing in the future? And are there any developments that are exciting and you're excited to see implemented in the future? So who would like to take that one on first?
So let me start because I love the question. The telecommunication industry is going through a big disruption. I think the pandemic has changed the nature and role of communication forever. What we found during the pandemic is that our connection to each other over the communications networks is essential in our lives. And for those of us that have people distant, obviously it's always been essential, but it's even more essential now. We saw communication allowing us to work from home successfully and learn from home successfully. I don't think any of us before 2020 would have appreciated that this was possible, but I think we showed during the pandemic. It's not the same as being in person. We still need to get together in person, obviously, but we can be very productive. And so that was sort of an event forced by the pandemic that allowed us to learn why telecommunications is so darn important to the world, to our society. But it also showed us additional aspects that make it a challenge for those of us in the telecom industry, in that expectations are so much higher. If your connection isn't working properly and you have your 6-year-old in front of the TV, in front of the computer screen getting taught, no, this is simply unacceptable. It is simply unacceptable. And so as we transition from thinking about our connections, the fiber to the home connections or our wireless connections, being a nice to have, today they really are a must have. It is essential infrastructure that we have. It is not an option. In our society, we're seeing newspapers disappear and being replaced by our connection to the news, the information that we need as citizens to be good citizens, only available over the communication networks that we provide. I mean, can you imagine a bigger responsibility that we have than that? And so it's a fun time because we're seeing all these new opportunities that are there. It's a fun time because we are really being challenged to have our connection, either wireless or optical or IP, be seen as an essential part and increasingly being challenged as sin is wanting us to be challenged. We're definitely being challenged in the performance of the network. So I think it's exciting. Lots of developments within that, but think about the move from best effort networks of today to deterministic networks of tomorrow, which is the language I use with the teams that I lead.
Good. Thank you. Dragon, would you like to share your thoughts on the industry?
Yeah. Working with students and, of course, reading the technical articles, people may say communications, connectivity as the topic, and the industry got matured. And you're right. As I said, I started as a young grad student working on 2G to 3G and then 3G to 4G. And you would say, oh, all the machine learning, deep neural networks, this is so much more interesting, so much more around us. But I would like to emphasize a couple of points. Connectivity is still essential to all of those things you've been reading and hearing, receiving kind of headlines in the news, be it ChatGPT. Guess what? There is a lot of transfer between your terminal and the cloud. Connectivity matters so much. And this would be just voice. How about when we start doing video? Without naming names in terms of companies, certain autonomous vehicle companies are basing the brain of this system actually in the data centers, in the cloud. And connectivity here is essential. And to add to it, information, this is my favorite expression, it's very much physical. So we're hitting hard problems in terms of communicating how many bits per second per hertz you communicate through a limited resource, and then coupling it with compute. So what's going on? There is a very strong merger of compute and communicate, enabling all of those interesting applications that we're hearing about on a daily basis. So yeah, it has matured, but there is so much work yet to be done. And for a young engineer, a grad student, this would be an excellent topic to focus on and build on, considering what's been done over the last many decades. Alexandra?
Yes. So on top of what Todd and Dragan mentioned, I see like three big axes of development for networks, meaning the capacity, the energy consumption, and connected and binding all that is the cost of the network. So I think there are great opportunities for innovation to take the most capacity of the medias we are using, whether it's wired or wireless. And then looking at the energy consumption with all the environmental focus, but also power may actually be the limit on how we can grow our system. So here looking at the optimization has a great potential. And last as not least, I think money is kind of a bit guarding and shaping the world we are living in. So it of course needs to be economically feasible in the end. So looking at innovations, optimizations, using the best of breed, there are also great opportunities for telecom.
Okay, great, thanks. Just to expand on the concept of ideas for what to work on, where do the great ideas come from in your organization? Where do you find inspiration? How do you get to those big, important problems that you can work on and solve and make a difference in the world? Dragan, you want to start?
Well, I think during the course of my career, usually you start with a healthy technical problem, which is typically rooted in human needs. So you get a practical problem, then you try to understand which is always fun, state of the art. Try to understand at least to a degree fundamentals, and try to improve upon. And it's an iterative process, innovating, learning. It's very much a turbo iterative process. With every iteration, you are improving upon, and sometimes the gains could be small in terms of new knowledge, and sometimes could be big jumps. It's hard to tell when either of those happen. But rooted in real problems, technical problems, satisfying human needs, it's a great starting point. And what I said early on, drilling down, reading conference papers, publications, previous standard definitions, that's how you become an expert and start innovating.
Todd,
Those were the things that worked for me over the years.
Okay, great. Todd, do you have thoughts on this as well?
I do. Historically in Bell Labs, we have a model that I subscribe to and I try to think about myself. And that is, historically in Bell Labs, we've had a vision about where we thought society needed to be. And of course, we've always been in the communication space. So in the communication space, where would we like to be as a society? So not Bell Labs or Nokia or anybody, but as a society in 10 years. And then think about in our own spaces, whether we're working in wireless or optics or semiconductors, what are the things and inventions that would be needed in order to get us to that point? So the example I normally give in this space is communication between Europe and the US. And so we were communicating over copper lines on the bottom of the ocean. It was just telegraph. But we realized there was something more needed. And so we postulated about bouncing radio waves off of silver balloons in the atmosphere in order to get a radio signal. And so the radio antenna designers made these wonderful radio antennas that would point a beam at this silver balloon in the sky. And we realized we needed gain in the sky, and so the semiconductor folks invented solar cells, and so that's where solar cells came from, because we needed to harvest power at that balloon in the sky, and so we together, whatever our discipline was, we sort of have this goal of where we think we need to be. And oh, by the way, we got a couple of Nobel Prizes out of that too, from figuring out the Big Bang. So that was an accidental Nobel Prize, as are just about all of them in Bell Labs. So fast forward to today, what are Dragan and I chasing? So we think that we've done a pretty good job of connecting people. So pretty much anywhere on the planet, you can get a connection. Only about half of the planet is connected, so we still have work to do, clearly. But see that to be as much an economic question as a technical question. But let's forget it. That's a problem that we need to solve. So we think we've connected people pretty well, but what we don't think we've done quite as well, and where we think there are opportunities, is connecting the machines that help people. And so you've all heard of Internet of Things, so I'm not telling you anything really new, but each of us are thinking about what is it that is going to be needed if we expand communication to not just voice calls like we had 40 years ago, or texts, but really a much richer set of communication to the machines that help people, whether they're cars or AI systems that are helping us in some way, or security systems that are helping us in some way. What are the needs for that sort of an industry? And that gets me back to my point earlier, is one of the things is reliability. You need a reliable network. If you're going to be driving a car, you can't have the network disappear. So it's driving reliability. So whether we're working in wireless or in computing, like Dragan is doing, or you're working in optics with the growth and capacity needs that you need, that's the way we're sort of, that certainly in Bell Labs, we have historically determined what to work on next.
Okay. Alexandra?
Yes. Great idea. So I really like to start with understanding the users, the clients, the users' needs. So yes, Todd was referring to the pandemic's time. We can take the example over here: the need for connectivity, the need for capacity, the need for interaction, and then having some sort of tools. We can make if we have a hammer, we can make the problem look like a nail, right? So within each of the areas, technical areas we are working with, we can think of how to contribute to those. So there is always a possibility to step into the problem solving. And then I think it's about people, a bit of brainstorming, a bit of freedom and clear head. And then like the Archimedes eureka moment, I often found myself just stepping a bit out of the problem and seeing it a different angle. This is really where the simple yet powerful solutions are coming.
Great, thank you. The next question was positioned as it relates to the research going on advancing 5G and 6G at Nokia Bell Labs, but clearly I think all of you can answer this question. What are the advancements that 6G will bring?
Okay, let me try. Yeah, let me
It's
try
just a
to
good hard
answer it.
question, by the way.
Yeah, since so let me try to be brief. 6G, it's in a very early stage, even though people started roughly working on it a year, 18 months ago. So many things are wireless, up in the air, but a couple of key ingredients are emerging and are being worked on. First of all, usage of different spectrum bands, allowing for even larger number of antennas, extreme massive MIMO, meaning thousands of antenna elements. The other aspect is bringing artificial intelligence, whether in a form of a deep neural networks, throughout the network, possibly the whole physical layer, digital front end layer 2 being built in an extreme as a large neural network. Again, this is still all exploratory. And the third ingredient I would add, or a feature, would be using wireless not just to communicate, but to sense environment around. We call it at Bell Labs joint communications and sensing. So those are just three features, but there could be more. And I'm not sure which of those will become a dominant one, where we've got at least 5 to 7 years before we start seeing real 6G products, even though the research and patent generation, publication generation started. But underneath, it is about power efficiency, energy, merging compute and communicate at cost, energy, and considering economic aspects. And of course, the new applications that may drive it further, whether it's some sort of virtual augmented reality, some sort of interconnected vehicles. So applications and technologies, features I have mentioned. The last, yet again, a repetition, still everything up in the air, and things will be shaping up in years to come. So if you're a young engineer researcher, it's the right time to join the 6G research activity. Okay?
Thank you. Todd or Alexandra, do you have anything to add to Dragon's thoughts?
So every generation is trying to fix the problems of the previous generation. So 3G meant to add data. We learned with 2G that texting was kind of fun, so we tried to do it a little bit better. With 3G, it didn't quite work well. It didn't align with the internet that much, and so 4G was fixing that problem. 5G, obviously much higher speeds. So what is it that's not working in 5G that we want to fix in 6G? And one of my pet peeves, and has been for 20 years, as the Dragon knows, is being always connected. So there are places, it might be in my basement, it might be out when I'm taking a walk in the mountains, where I am not connected. Um, and I believe we should aspire as a society to have the ability to be always connected. So what does that mean for 6G? Well, I think it means it would be great to have a better um, coordination between Wi-Fi and 6G. It would be great if 6G had a component that included satellite communication in a seamless way. But getting to the point where you didn't have to question whether or not you were connected or not, you knew you were connected wherever you were. And my gut tells me that if we are successful at doing that, the number of applications just explodes. I mean, for me, I have a 87-year-old mother who falls every once in a while when she goes on her walks, and I'd love to know, no matter where she is, that she fell. And so that's you need a high reliability connection and the ability to connect her everywhere in order to be able to have that sort of an application. That's just but one. And my mother's in good health, so it's not really a worry. But that's an area where I don't think we did as much as we could have in 5G. So is a problem that I'd love to fix.
All right, great, thank you. Alexandra, did you have anything to add?
Yes, so I definitely agree with directions that Dragan and Todd mentioned. Maybe I can highlight the impact on the software-based solution. So as much as optimized hardware is always at the foundation, but then the economy of scale can really kick in by adapting this hardware, this general hardware by software means for the specific use cases. So yeah, I think the important research areas are still within the resource virtualization. And here also the AI/ML frameworks are kicking in to optimize the services and algorithms.
Mm-hmm.
Great, thank you. Some of the questions that we've received go back to growing and evolving your skills and your training. And one of them was based on a talk that was earlier today. When you're trying to develop yourself outside of the classroom, where do you go to supplement that academic training? What can you do to be better trained on your own, not in the classroom? Alexandra, do you have any thoughts on that?
Yes. So definitely what works for me is reading books. There are various recommendations on the fields that are of interest. Then talking to people, really looking at the everyday problems, listening on what are the keywords to check, podcasts to listen to. So those would be like my main sources. And then there's really such a multitude of resources available online that I think the interesting part is to go to the right ones. So here again, recommendations work the best.
Great. Dragan?
Yeah, I'll emphasize which is something or give you an example which is a bit specific to my style. Would be these kind of hands-on experiments, and these days you would have access, thanks to the open source community, open hardware community, to many different sources to do such a thing. I'll give you the most recent personal example. We've been discussing AR, VR, these new types of fully immersive experiences in the virtual augmented world. And I decided to check from the connectivity perspective, the character of the traffic between VR goggles. Namely, I bought Oculus 2. And guess what? It's got a very kind of open source, widely available gaming framework called Unity. And there is a Wireshark, a tool which has been available and evolving during the last couple of years, decades, to analyze the IP Ethernet traffic. And I've been having a lot of fun doing some measurements, experiments, repeating it, becoming a bit more versed, and learning stuff through the hands-on experience. So my advice is for those which are inclined or they need this type of attention-keeping, hands-on exercise, that there are a number of resources available, open source, open hardware, evaluation boards, different type of tools which these days support such a work even from home without needing an extensive lab. Does not work for everyone, but if you find that this somehow works for you, be on a lookout and actively try to find what fits you. And if it does not fit you today, look for something else. The world is big and rich when it comes to those things. Okay?
Great. Thanks. Todd?
So one thing that I've found, because I manage folks here in the US as well as in Europe, one thing that I found is supported perhaps better in Europe than it is in the US is the nature of internships. So if you're a student going to a university in Stuttgart, there is an expectation that you spend 6 to 9 months as an intern at a company. And companies like ours kind of have a social responsibility to support that, and we do. And I see those internships as a wonderful way to see the way that the scientific and research and telecommunications work. But although I would say internships are probably important no matter whether you're in telecom or not, but that experience of seeing how things work and seeing how decisions are made and what sorts of skills you need to be able to help in answering the questions is wonderful. And it doesn't mean that you need to stay in that field the rest of your life. You're experimenting, you're exploring and seeing, geez, is this an interesting area? And so certainly it can guide your technical interest and direction, but perhaps even more important, it teaches you about the way that people interact in solving problems together. So that's obviously important because research and R&D in any company is related to the way that you interact together as well. So I would urge you to exploit as many internships as you can, because you'll gain numerous experience as well as the contacts for later, and those are important too.
That's an excellent point. I also want to mention that ComSoc, the Communication Society, has instructor-led training, has technical groups and standards, summits, publications, conferences. Have you any thoughts on how the students might take advantage of things that are offered by the Communication Society or other societies that are aligned with their areas of interest? Todd, you're nodding.
So definitely. I mean, it's been one of the additional benefits that came out of the horror that was the pandemic, that we have a lot more opportunities to learn online in courses from universities as well as from the IEEE ComSoc. So I think there's more than ever opportunities, and so I see this as this transformation that's happening of learning where you have to go to a place and pay an enormous fee in order to gain exposure to a different direction, to now it being a lot more open, to being a wonderful positive development, and one that I think can advantage the developed world, but I think it probably even more advantages to the developing world, where they just simply don't have access in the developing world to the same opportunities. And here's a way to be able to learn from the best in the world, no matter where you happen to be. So I would definitely encourage you to take advantage of all those opportunities, including those at ComSoc.
Alexandra?
Yeah, I'm a big fan of knowledge sharing at conferences. So now with the possibility to attend online, it definitely makes it easier in some cases. And there's always something interesting to hear about, whether it's people's approach to problem solving, the tools they are using, different soft skills that are being trained or discussed. So I definitely greatly benefited from attending various conferences, whether in person or online. And yeah, there are multitudes of options.
Yeah, I can say that IEEE is great since it's presenting us students, engineers, experts with a spectrum of conferences in terms of topics, but as well in terms of sizes. Sometimes you'll like those big industrial where you've got these very nice panels, which I enjoy greatly to listen to. Top-notch industry experts attending, and it's always fun to be in the audience. Or these smaller, more kind of topic-oriented, a little bit more intimate conferences, so to speak. So IEEE is doing a great job when it comes to organizing those, and especially Com Society. I would just say as well for young researchers, try to get involved in the review process. Sooner or later, after submitting, you'll be asked to contribute to reviewing. This is very beneficial. It tends to be hard, demanding. That's part of the service. But in the end, a reviewer benefits as much as the contributors you're doing the service for. So these are the 2 quick points. Okay.
Great. Thank you so much. So Nancy, do they have a minute to do a 1-minute wrap up, or
just one? Yeah, because we're getting a little close to over.
Okay.
But again, what an amazing conversation. So,
Absolutely. So I do want to thank all our panelists. If you could please take 30 seconds, we just halved it to 30 seconds to wrap up and share any last words of wisdom to our students. Todd, can you kick us off?
So telecom is hot. So study in telecom. Don't go to those other applications things. Telecom is hot.
And telecom has it all, right? Okay, Alexandra?
Yeah, telecom is hot and telecom is fun. So yeah, just be open-minded to what drives you and what is needed, and enjoy the way, enjoy the drive.
The world of science and engineering is great. You're surrounded by great people, and the topics cannot be better. Just stay true to it and give it some time, and you'll enjoy it greatly.
Thank you all so much. I really appreciate your words of wisdom. I thought you had some great contributions for the students, and I appreciate you spending your time with us today.
Well, thank you so much, Sin, and all the speakers here. You've been amazing. We really appreciate the partnership with Communication Society. We'll go ahead and promote all of your stuff. We really want students to join and get engaged with your society because you do have so much to offer. And the experts, as evidenced by your expertise and who we can meet today on this call. Right now, starting over on another session is going to be a conversation with our young alumni about pivoting, because your life and career is all about transitions. And so how do you pivot and deal with the different transitions, the things that are definitely going to come up? Like you said, life happens. So please join us over there. But for now, thank you very much for attending this session of a Fireside Chat with these experts from the Communication Society. And I appreciate your being with us today. And we'll see you around Pathways.
Okay. Thank you.
Take care.